Hello everyone, welcome back to the next installment of Stoss's detailed interior Type VIIc tour using Wolfpack by Usurpator Games. They've made their very nice interior of a Type VIIc, and I've been using that. If you've been watching my previous videos, I've been using that as a vehicle for giving a tour. And to the extent that there's something that's not modeled in here that I feel is important, I've started supplementing with pictures as well to help people get an understanding of what these things look like and how they functioned. So this one is going to be about the after part of the control room. So if you recall in the previous video, I covered the the forward section of the control room, and I kind of used the attack periscope well as kind of as my cutoff, but actually there are a couple things up here just that are sort of on the border that I didn't cover that I'll cover in this one as well. Right, so lots of important systems, lots of important functionality in the aft control room, not implemented necessarily in the game, but in reality, this area was chock full of interesting systems, and certainly very important systems. So I will cover those as we go here. So the first item we've got is the echolot. Echolot, that's your depth sounding device. Most people are familiar with how this works. Wolfpack has modeled it, and they've modeled it pretty accurately. This device had a shallow sounding, so an ultrasonic mode, and then it also had a deep sound. That shallow sounding was actually more or less noiseless, and then the deep sounding mode did emit an audible ping. It had really three ranges. The first range was from 0 to 125 meters, next one being from 0 to 1,000 meters, and then there was actually some models had a range of 150 to 3,000 meters as well. The real device did have these two scales on it like this, and there was a switch on here to switch between the ranges. And then also between sonic and ultrasonic modes. It had a headphone jack on it as well, so I believe in case this actually did work like this in real life, where you had a little neon light that would flicker behind here and show you and flicker at the depth that of the result that you got back. And I believe if that failed, there was a headphone jack on here as well in order to hear the audible sound return, and I would assume it's because it's a backup in case this optical arrangement here failed. Okay, so that's the echolot. Pretty self-explanatory. Very important piece of equipment, obviously. Before every dive, regardless, sounding was always taken, and the chief engineer, in other words, also had the responsibility of being the dive officer, was informed over the current depth of the water. Just in case it was too shallow to dive, and they would need to abort. Okay, so that's the echolot. I'm actually going to move forward a little bit and talk about there's a water density measuring device that was in two different places depending on kind of what boat you're looking at. For this one, it's not modeled in Wolfpack. It was right here, which is, if you remember from the previous video, this is the area that has the port negative tank controls are here. The water density measuring device is actually here, and let's flip over to my screen over here to see what that actually looked like. So we're facing the same area. This pole here is the radar, the Fumo 30 shaft, which I'll talk about in a minute. But that's to sort of orient yourself to where we are. That's where we are. This right here is the tube to measure water density. Now, water density is a function of two factors. That's water temperature and salinity. Salinity being the salt content of the water. Why would they care about this type of thing? They would care because of the need to maintain accurate records of trim of the boat's weight, and it's actually incredible if you think about all of the different factors that would affect the trim of the boat and the buoyancy of the boat. Things like water temperature and salinity, or even plankton content, which this won't measure necessarily. All that type of thing can affect the trim of the boat, can affect the buoyancy of the boat to the extent that the boat needs to do, and I covered this in the previous video, a daily trim dive, or as the Germans call it, a Prüfungstauchen. A Prüfungstauchen is more of like a check dive, is more the accurate way to describe it. Like a check dive is required every day, because the changing temperature of the water, the changing salinity, plankton content, obviously the changing weight of the boat itself due to consumption of provisions and fuel, etc. All of that needs to be taken into consideration. This water density here calculation is also something that needs to be taken into consideration, okay, as part of your trim. So they would measure the water density and then adjust the regulating tanks and or bunkers as necessary. Okay, so that's what that is. Very inconspicuous piece of equipment, but nonetheless, it would be. So this was where we were looking kind of on U995. There is right here. Okay, I neglected to cover this shaft here in the previous video, but what that is actually that is the shaft for the Fumo 30 radar. The Fumo 30 radar is this unit here. Now U995 is missing. The Fumo 30 had like 4 pieces to it. This is actually missing a couple pieces, and they would have been mounted here. But this antenna here is actually the rotatable giant. And this is the radar antenna. If you ever see pictures of later war U-boats on the bridge, it looks like chicken wire. It's like a big, rectangular chicken wire antenna. That's what that is. That's the Fumo 30. It had Fumo capability and FUMB. So Fumo being Funkmessortung. Funkmessortung is your active radar, and then Funkmessbeobachtung, FUMB, Funkmessbeobachtung, that's your passive radar detector. All right, the Fumo 30, I believe, had both capabilities. Okay, this would have been rotated actually by hand wheel that was like right about here or so. It's not in 995 anymore, but at any rate, so that's the radar here. So it really doesn't technically belong here in this model because of it's a bit of an anachronism, because it's this, a boat in 1941 is a ways away from having any sort of radar on it. Okay, but that's, at any rate, that's the shaft for the Fumo 30. All right, so we're going to actually swing over this way now and cover these two bad boys here. So these are your hydraulic pumps. You've got 2 of them, and as is the principle on a submarine, of course, you've got more or less, it's not always the case, but more or less 2 of everything, right? You've got the left one here, or the forward one, is your auxiliary hydraulic pump, and the right one here is your main hydraulic pump. Now, what are these used for? We already covered the fact that also that the hydraulic oil tank reservoir is here. You can see the top of it right there, and then the accumulators here, which there should be 3. There are 2. These are the hydraulic accumulators, the containers essentially for pressurized hydraulic oil, in order to run the various components that run on hydraulics. Now, what are those? Those are I covered these. I touched on these in the previous video, but both of your periscopes have hydraulic elements to them, and then the snorkel as well. In a later boat that had snorkel, the snorkel was raised and lowered by way of hydraulics. Now, the periscopes, the night periscope, the control room periscope, that was obviously turned by hand with the handles, but it was raised and lowered by a hydraulic motor, which we covered in the first video, or in the previous video rather. And then the attack periscope in the tower was raised and lowered by hydraulics, and it was actually turned by hydraulics as well. There were foot pedals on it. Most of us are familiar with sort of how that worked. We'll cover it more when we get to the tower interior, but that periscope had foot pedals, and you steered the hydraulic drive by way of you push the left pedal, you're going to turn to the right. Push the right pedal, you're going to turn to the left, and so on and so forth. And that was also driven by a separate hydraulic motor. So really 2 hydraulic motors going on for the attack periscope, with 1 for the night periscope. But these are the hydraulic pumps themselves, okay, to pump oil into the accumulators and then on to feed the various hydraulic motors that are aboard the boat. Okay, so that's the hydraulic pump. Those are the hydraulic pumps there. Moving over here, so this device here is the distilling unit. The boat had the capability of distilling fresh water from salt water. This unit was fed from a saltwater intake that's actually shared by the flooding and draining system, which I'll cover in detail and a little later in this video. But they haven't modeled this super accurately, but you would see the C valve for that intake for seawater that would feed these systems right about here. And that would flow in here, and then you'd have also a couple other valves in here to admit seawater into the initial holding tank here, which was here. What would happen is you've got a heating element here that heats the seawater up, and then also preheats the seawater as before it gets into the unit, but it heats it up to the extent that it evaporates, and you've got water vapor left over, right? And there's a compressor in here that forces that water vapor into a condenser, and then from that condenser, that condenses the water, the vapor into a freshwater component, and then that actually gets pumped to freshwater tank or drinking water tank 1, which is by the galley. Okay, and you've got really the residual heat that comes out of this is actually cycled back to sort of the holding tank for the seawater to preheat it before it goes back into the system again. And so you've got seawater coming in, being heated. That water vapor, the seawater is evaporating. You've got water vapor left over. A compressor pushes that into a condensing unit, and then that condenses your water vapor into fresh water, and then that is supplied to the drinking water tank 1, which is further aft. In terms of output, this could put out about 4 gallons per hour, kind of a maximum capacity, or really an average capacity or output rather, is about 4 gallons per hour. Now, we touched on this, I believe we touched on this before, probably when we covered the forward head, but again, you've got several demands on fresh water. You've got your batteries needed. You need to introduce distilled, filtered fresh water into your batteries, maybe on a monthly basis. You've got probably the biggest consumer is cooking. So the cook would have really ultimate say over what amount of water he's used and how much water is then left over for use of the crew. I talked in a previous video about some boats having a budgeting system, like a bank type of system, where everybody gets sort of that leftover water sort of allocated to them after the cook has or the motor machinists have accounted for all the water that they need. Any of that extra then is allotted to the crew for washing or drinking or whatever the case may be. Okay, so this is where it comes from. You've got your distilling unit here that's creating your fresh water, and then that is getting pumped aft. Now there is a control box up here that's not modeled, so I'll show you what that looked like on. There's this virtual walkthrough, and I can actually link this. I'll link this in the description. This is actually a pretty cool walkthrough you can use to look through the boat and just poke around. And you can't get into the nooks and crannies, but you can at least walk through the entire boat and sort of see these nice, high definition pictures of the submarine. But this up here, so here's the real distilling unit in the boat in 995 right here. If you look up here, you'll see the control box for this. So this would be how it would be started, would be up here. And then another interesting piece of gear that's right in this immediate area is this little nozzle here is actually you could insert like a female end over that, and this is actually the drinking water selector valve to select once the drinking water collects, and as I mentioned before, this comes out here and goes into drinking water tank 1, but there's also drinking water tanks 2 and 3, and so from there you could supply tanks 2 and 3 by way of a hand pump that was in the galley, but this was actually a way for you to select which which drinking water tank you want it to pump to, either 2 or 3. So drinking fresh water goes to drinking water tank 1, and then it's pumped by a hand pump in the galley, and then this delineates which direction it goes, which drinking water tank it's going to go to. Okay, so that's the distilling system, really. I am going to, let's pop back to Wolfpack here. There are a couple other things here that I want to talk about on the bulkhead. So there are a couple of what I call transfer switches. I guess I'm not sure if that's really the appropriate name for them, but these things right here, you see several of these throughout the boat, right? And they're very important because typically this is providing some sort of connection from a power source to an end user device. And in this case, the one that they've got here is likely meant to be the most prominent one. There were 2 here, and I'll show you what those look like in a minute here when I'll go back to 995. But if I go over to the starboard side, this is a little slow on me right now for some reason, but if I scroll over here, you'll see what I mean. You've got a selector switch here, or a transfer switch here, and then you've got a smaller one down here. And what these are, this one here, this larger one, is actually it's the transfer switch to designate what the power source is that's going to feed auxiliary switchboard 2. We talked about auxiliary switchboard 2 in the previous video of the forward part of the control room. This right here is your auxiliary switchboard 2. This transfer switch designates what the power source will be for that. I mentioned in the previous video, the power source can either come from main switchboard 1, which is in the E-motor room, or it can come from the battery. Okay, so that's that. The switch immediately below it is the power switch ultimately for the main drain pump here. That's this device right here. It's not the on-off switch per se, or it's not really how you turn it on to operate it. It's really providing the power to it, and it's also selecting what mode you want the pump to be in, whether that's in series mode or the pump has 2 impellers in it. It really sort of 2 motors, if you want to think about it that way, and those can be either run in series mode or parallel mode. The difference being, of course, series mode is going to give you more sort of pressure head power, sort of the power of 2 pumps, whereas parallel mode is going to give you more volume of flow. Okay, so that's the difference there, and we'll touch on why you might want the different settings a little later. But anyway, this here is the switch to really provide power to the main drain pump, and then to select series or parallel mode for that. Okay, and then on the other side, and forgive me because this panning is really a lot slower than I thought it was going to be when I'm on the video, but if we go slowly over here to the other side, you will see a similar one, and that would be for the trim pump. This right here is your the technical name for it is your auxiliary drain and trim pump. Hilfslens- und Trimpumpe in German. So you've got that there, and this here is the switch to provide the power, not to start it, not to run it, but to provide the power to the auxiliary drain and trim pump, or sometimes we just shortcut it, we just call it the trim pump. Okay, so that's that piece there, and let's just check in Wolfpack to see. They don't have that piece modeled up here, but excuse me, let's look over here. Yeah, they don't have. Instead, they have this box up here, but that's where that was right there for us. Okay, if we move over here, we'll cover this whole area here in detail as far as the functionality, but this basket right here is actually the location of, so the submarine had a refrigerator, and that was located in the next compartment aft. That's the petty officer's quarters, right on the other side of this hatch, right on the other side of this bulkhead, was the refrigerator unit. It's very small, couple feet by couple feet, cube essentially, and that actually has to be run, by a compressor, like a Freon unit, and that unit, that motor, that compressor, was actually right here. That sat right there. And what that looked like was that actually looked like this right here. You can see, so here's the trim pump for, or excuse me, the main bilge pump right here, and then you can see the these, we'll touch on what these are in a minute, but right there is your compressor for your refrigerating unit. Okay, courtesy of engineer guy for this picture. This is actually a picture of U-98. Wartime picture of U-98, and so he was kind enough to provide many of these pictures for purposes to help out in the video. So that's the compressor unit for the fridge. All right, so we can go back to Wolfpack here, and we'll talk about this fuel selector up here. So this. We touched on how the fuel measurement selectors worked in the previous video. This one is the one for the internal fuel bunker number 1, which is here and extends back around the battery, which is under the floor plates of the petty officer's quarters here, and extends aft. All right, so that's your internal fuel bunker number 2, or excuse me, number 1. 2 is forward, 1 is aft. And you've got the same functionality here for measuring the fuel that's in there by way of the fuel selector up here. Very similar, in fact identical in operation to the one in the previous video. Again, just to reiterate how that works, you've got a few different settings on here. You've got a setting basically that you would switch it over to, there'd be a big handle on this. You'd switch it over to a setting that would allow the fuel lines to fill up, and it would equalize the pressure across all the lines, and would allow all the lines to fill up, and it would also allow the center drain pipe to fill up with some combination of fuel and water. Fuel, of course, floating on the water. And the whole idea here is then you would turn it to the next setting, and then that would isolate just the contents of that center pipe. And then there's another setting on here that would allow you to drain that contents of that center pipe then into the collecting bucket here, which they've modeled. They didn't model the one forward, but they've modeled this one here. And again, on 995, it looks like this, but it's like welded shut, and it looks sort of like its own little container. But it's really literally a removable bucket, a bucket with a handle on it. Very kind of rudimentary looking, but it really was. It was just a couple of pipes that emptied out into a bucket, and then you would release the contents of that pipe into the bucket, and you would stop when you saw water, and then you would take the contents of that back into the diesel room, and you would pour it into a measuring, almost like a container or beaker or whatever, and that drained into the fuel. There was a fuel collection tank that was beneath the floor plates in the diesel room that basically ensured that you weren't wasting any fuel. It just went right down back in there and it was reused again. But you've got so you've got that ability to test your fuel for this particular fuel bunker by way of this bucket. That's the one for the aft portion here. Now, you will recall that we had fuel ballast tanks for port and starboard that were forward. Now we have fuel ballast tanks, or FBTs, to port and starboard, which are further aft here. You'll recall, and for FBTs 4, we had the ability to actually test that into the forward bucket. We actually don't have that ability here. That testing is actually the testing valves for that to admit the fuel and or water or whatever is floating at the top of those fuel ballast tanks, to admit those into a bucket actually in the diesel room. It's actually further aft, because those FBTs 2, those fuel ballast tanks 2 in the saddle tanks, are long and they extend all the way back to be adjacent to the diesel room, and that's where the testing occurs for that. So that's why you only see a couple of pipes in here versus several pipes that were converging on this bucket that was up forward. Is for that reason. Okay. All right. So that's the fuel measuring, the ability to measure fuel from the bunker here. The reason, and then the other thing is there's two. You'll notice there's two lines, but we're only really concerned about one tank, one bunker, and why might we have two lines? And it's because I believe the second line is the ability to just directly, because those fuel bunkers are constantly under pressure. They're under pressure from the compensating water system. I'll cover this in detail in the diesel room, but just to reiterate on it, water comes up under the winter garden into a tank that's cooling water that's been heated through the engines, and from there gravity pulls it down to fill up the various fuel containing tanks and bunkers. And that happens in the internal fuel bunkers, and it also happens in the fuel ballast tanks. And so of course you've got a pressure head coming down, exerting pressure, water pressure on the contents of those tanks. So therefore, if you open a valve to try to test it into one of these buckets, you're going to have that pressure behind it. So you're going to admit it in there. So I believe this second one here was just more of a direct measurement of whether you've got fuel or water basically flowing at the top. I think that's the case. Okay, so that's your fuel measuring selector cock up there. Okay. All right, another prominent feature of the aft portion of the control room is the gyro compass, and the gyro compass system. Okay, you've got the mother compass here. So in German, that's a Mutterkompass. This is your gyroscope. Your gyroscopic compass is here, and this feeds several what they call Tochterkompasse, which are daughter compasses, which are in English you would call it a compass repeater. That feeds several of those throughout the boat. Now you've got some boats only had one in the control room, some boats had two. So you've got your one here at the helm station, right? And then some boats actually, like U96, I know they had a compass repeater right about here at the chart table. So there were two there. You had one up in the tower, and then you had two up on the bridge. You had the one that was at the attack periscope well, and then there's also one forward on the bridge for the helm. If the helmsman were up there at maneuvering stations coming into port, he could use that up there, or just whoever's up there on watch or whatever for reference. That's up there as well. And then you've got one in the radio room, and then you've got one in the listening room. So there are several daughter compasses that all have connectivity to the mother compass here. Okay, so that's how that works there. There are keys that you can use to adjust the daughter compasses to realign with the mother compass. When you look down in here, you're able to see what the reading is of the actual gyro compass itself. It would be the duty of the navigator to make sure that the mother compass, that the daughter compasses were all aligned with the mother compass, and they had a little wrench that they could use to adjust that. Okay. The gyro compass itself wasn't really turned off very much. It wasn't actually very loud. It was practically inaudible to an external listener, at least for several hundred meters. This thing took like hours to spool up, something to the tune of like 2 to 4 hours or something like that to actually spin up. Because the way this works, of course, is you've got this gyroscope in there is spinning, and that centrifugal force in there is causing that compass to automatically align with true north based on the rotation of the Earth. And so that's how a gyroscope. But that spinning up to get to that point takes hours and hours and hours to get it all spooled up and running at the correct speed, and to really align the gyro compass with true north. So the advantage of a gyro compass over a magnetic compass is you have no deviation to take into consideration, because the gyro compass operates off of true north instead of magnetic north. Very, very important distinction, and the main advantage of a gyro compass on a naval vessel. Okay, so part of that system, you've got these two units here. These look approximately correct in real life. They look like, if I scan over here, whoops. If I go over here, you can see here we are. These are them in real life. These are electronic amplifiers for the gyro compass system. Okay, they're amplifiers for the gyro compass system, and because the gyro compass is ultimately fed from the e-motor room, from the power sources in the e-motor room, and then these amplifiers are allowing the system to get the appropriate amount of power to run. And so that's what those are. You also have, this also has a pump associated with it. This is a cooling water pump. That's this unit right here, which I think Wolfpack is also modeled. Yeah, this right here. That's actually the cooling water pump for the mother compass. Okay, so that's what that is. And then there was also a switch box that was above the main bilge pump that was up here, which you can't see in this, and it's not necessarily worth a picture, but you might be able to barely see part of it. Behind this light is really where it was, but that's a switch box for the gyro compass system. Okay, so that's really that system there. Gyro compass, again, incredibly important, and generally not turned off. It generally wasn't a loud system. The pump itself was probably the thing that made the most noise, and even that wasn't super loud. Okay, all right, so the next thing I'll cover is this is also something that people tend to notice, and they don't really know what it is. There's this random device, and Wolfpack has put it in here because it's in 995, but it actually wasn't. This device was not here. This device in 995 is some sort of a transceiver that wasn't really carried aboard U-boats. If you look very closely behind that unit, you'll see a mount that is clearly designed for something bigger. You can see the mount starts here and stretches all the way down here, almost like a square. So this thing here is clearly out of place. And we know what was here, and it was actually a man pack. What we called in the military a man pack, or in German it's called a Tornistergerät. A Tornistergerät is a line of sight radio, like a whip antenna that like a soldier might carry. Okay, and so that was here, and so they actually had one of those devices on the aft part of the attack periscope well. And what did it look like? It looked like this. So you'd have your case. It would be sealed in a metal case, and I don't know why, for some reason my internet is so slow right now, but this is what it would look like here. You can see the square corresponds to what you're seeing and they have the full mount model in Wolfpack there. You can see it, but that would fit on there. Okay, and really it's a line of sight type of a deal, and it's voice. It's a portable radio to speak over voice. Here's the antenna right here that can extend up. So that's the Tornistergerät, the man pack. Now this device, sometimes you see it in pictures of boats on patrol, and sometimes you don't. I would say most common, at least according to my understanding, is most commonly this was not carried on war patrols. It was used in Baltic sea trials. The voice-to-voice element, there's really, for this type of a device, there's really no use for it on a war patrol. Boats are not using this type of like VLF voice transmission communication boat to boat. It's a very dangerous thing to be doing. If they're speaking to each other, they're not doing it over radio. They're pulling up alongside each other, and they're getting the old megaphones out, and they're yelling over ka on ka, commander to commander, etc., etc. What have you sunk? What'd you get today, etc. Or whatever. If they're part of a wolf pack, they might meet up with each other and speak over megaphones, but not using a man pack radio like this. This was typically something that was removed, at least my understanding, when the boat left for its war patrol. But at any rate, that's what it is. In 995, it's this here, and I'm not sure what persuaded the museum to put this device up here, because they actually do have if I remember correctly, the museum has the museum boat in the radio room actually has a Tornistergerät, or at least one that looks really similar to this. So it's actually, they have one in the boat They should just get rid of this and put what's in the radio room up here, and then they'd be complete in terms of historical realities. Okay. All right. So that's the man pack there. Okay. So let's move on. Talk about the elements of the ballast system that are back here. So you've got two wheels back here. Wolfpack has you operating these. They call it the aft ballast vent. That is technically correct, at least for the right-hand wheel here. So this wheel that's on the port side is the vent wheel for main ballast tank 1, which is way astern, okay? Way in the stern. This would be opened on a dive, as would the vents for all the other ballast tanks, with the exception of fuel ballast tanks 2 and 4 if they're in the fuel oil configuration, meaning they've got fuel in them. You obviously wouldn't do anything with those until the fuel was gone. But you've got on a dive, you've got venting happening, right? And to reiterate what that means, the bottoms of your ballast tanks are open, the tops are closed. The ballast tanks are full of air. When you release the top vents, when you open the top vents, the air escapes, the water flows in the bottom. Very simple, okay? But you're turning this one here. You're turning this one here to open main ballast tank 1. The way it typically worked on a dive is there'd be usually a 5-second pause between the time that main ballast tank 5, which is this wheel right here, was opened, and they'd wait for the chief engineer would wait for about 5 seconds before he allowed this to be opened, because he's trying to establish the correct amount of downward pitch in order to down angle for the dive. Okay. If that didn't happen, so you'd have one of the Zentralegasten, one of the control room sort of assistants, would be back here manning this wheel, and if after 5 seconds he didn't hear any order to flood, he would say Frage 1, and you can actually hear this in Das Boot. Sometimes you hear him say Frage 1, and that's what he's saying is, like Frage is like a question, like when you in German, at least the German military, you often hear like Frage this and Frage that. Like that means I'm asking you about this, asking about 1. What about 1? And then the chief engineer would say, all right, vent 1. So then that's just, he's reminding the chief engineer, Frage 1, like, oh, remember, we got to open 1 as well. So he would open that. Okay, so that's main ballast tank 1 vent here. You've got, I'll cover what this is in a minute here. You've got fuel ballast tanks 2 and 4. Again, I've mentioned several times now that those are typically in the fuel configuration, meaning full of fuel, with the Kingston valves at the bottom closed until the fuel is consumed in those, at which time the boat will be converted over into water ballast configuration. They would do that by opening the Kingstons, and then there were some valves that they needed to turn in the deck to turn off the compensating water that would flow down into those from the header tank to push the fuel out. Okay, that they'd cut the water off for that as well. Okay, so now let's assume that they're back in the water ballast configuration, and they're using those ballast tanks as water ballast tanks. They would vent those tanks, or in other words, flood those tanks on a dive, and those handles are here. Here you can see the one for the port side, right there, this thing here, and then you see the one for the starboard side. Now they have this placed way over here, and you would never be able to operate this in real life because you would bang onto the hydraulic pumps. It was actually here. It was here, okay? And here you can see 2 individuals actually operating these vent levers. This is on, I believe this is on U203. Here's the man pack. There you can see the case for it right there. So that's really what was there. And then you've got, and I'll use this picture for some other things as well back here. But here you go. You got some control room personnel here opening those, the vent levers for main ballast tanks 2 and 4. Now there's 2 levers, but there's 4 tanks, right? You've got fuel ballast tanks 4 port and starboard, and you've got fuel ballast tanks 2 port and starboard. It's because they had a common vent valve. There was one vent valve that there were 2 pipes, one that led aft from FBT4 and one that led forward from FBT2, and they converged on this one vent per side. And these levers actually operated the those vents that were common vent valves for 2 and 4. So both 2 and 4 were getting flooded by pulling these. Okay, but that's what those guys are doing. They're pulling down on those. All right, so you can see in 995 where those are here. You can see it's not over the hydraulic pump. It's way over here. This needs to be accessible. So there's one there, and then the other one is right above our heads right here. You can see it right there. There it is right there. Okay, so that's for FBTs 2 and 4 to flood them, to vent the tanks, meaning let the air out of them. Okay, assuming you don't have any fuel in them and you're in the water ballast configuration. Okay, so that's the vent levers for those. Again, very important. If you're in a dive situation and you're not using those tanks as fuel tanks, you've got to pull these. Okay, you've got associated with the fuel ballast tanks, you've got really a fuel ballast tank number 2, the after ones. You've got this wheel here. So this is actually not something that you would necessarily always turn like you do in Wolfpack, where you turn both of these. This is actually a residual vent valve. It's a vent valve for venting the residual air, getting the air pockets out of the after part of fuel ballast tank number 2 if it's in the water configuration and you're using it as a ballast tank. When you flood that and if the dive angle were too steep, then air gets actually, because of the construction of flaws in the construction of fuel ballast tank number 2, air pockets would actually get caught way aft in those ballast tanks. And if you have an inkling of physics, you know how problematic it is to have air in your ballast tanks when you're submerged. The volume of things increase and decrease based on atmospheric pressure, and as you rise, any air bubbles you have are going to increase in volume, thus increasing your buoyancy, and as you go deeper, they're going to decrease in volume and you will lose buoyancy. And so having air pockets in there means having a permanent variable element to your trim and your buoyancy that just shouldn't be there. You don't want air pockets. Not to mention the sloshing around of them at depth actually makes noise. Okay, so that's why when you are the chief engineer and you dive the boat, before you level off, you angle the boat up and down a couple times. That's called, in German, that's called Durchpendeln. In Das Boot, you had Boot ist durchgependelt. That means he's oscillated the boat up and down by a few degrees in order to wiggle the remaining air out of the ballast tanks. Okay, but this here is in order to completely vent that residual air out of FBT3. There's a vent valve here for it, and then there's also one in the diesel. There's ones in the diesel room that we'll see as well. They do the same thing. Okay, but this one here is just easier access in the control room. But that's what that's for. It's very little known. It's sort of obscure. But you're not turning both of these for the aft ballast tank. You're really turning this one, and then if you are in the water ballast configuration, you would turn this because you want to make sure that you don't have any excess air left in FBTs 2. Okay. All right. Okay, so then main ballast tank number 3, I mentioned that already. That is the largest ballast tank in the boat. It's really 2 ballast tanks, port, so MBT3 port and starboard. They're under the control room and they're in the pressure hull, but they're enormous. Okay, the vent valve levers for those are also here, and they are further aft than the ones we just talked about, than the FBTs 2 and 4 ones. So here's 2 and 4 ones right here, port and starboard. Now you move a little aft here. Right here is for 3. Okay, to vent the port tank and then to vent the starboard tank. You yank these down, and that's always happening because regardless, fuel is never in MBT3. MBT3 is always a water ballast tank, and it's the largest water ballast, most important water ballast tank on the boat. So you're always pulling these down. That's MBT3. Okay. All right, so that's those. So now on the overhead here, you got some valves. Now one of them is missing here because they've gone off of 995, and 995 is actually missing the one of these, and I'll talk about what these are here. So there's really three here. There's one head valve here, and there's a head valve here, and then there. So I'm going to actually supplement with the picture that I just talked about here because this shows it perfectly what a typical Type 7 would look like in the overhead for the after part of the control room. So you've got this in 995. What exists is this head valve here and this head valve here. This one is actually missing. What these are is these two back here are the respectively the air intake. This is ventilation air intake head valve and ventilation air exhaust head valves. And then this here is the diesel air intake head valve. So what's happening sort of from an airflow perspective here, these head valves are open on the surface. This one here will admit air into a trunk that will go to the diesel room. There's a related foot valve for the ventilation air intake in the diesel room that will cover, but air will come into there, and then it will get cycled by the there are two ventilators in ventilating units that are in the diesel room, and those actually, when those are in operation, they cycle air throughout the entire boat. So they're really refreshing the air throughout the entire boat if you have those. In German, that's called Raumlüfter. If the Raumlüfter are on, and there's different configurations that they could have it in, but you're basically cycling air throughout the entire boat. It's coming in here. It's flowing through the foot valve down into the diesel room, and then it's getting pushed by the starboard ventilator, which is the ventilator for cycling air intake. That's pushing it throughout the boat. Meanwhile, the ventilator on the port side is pushing the exhaust back out through this head valve here. There's an associated foot valve in the diesel room on the port side, and then this is the head valve here. So you'd have the bad air effectively coming out of this head valve here. These are actually the pipes for these, and the intake and outtake actual head valves are up under the winter garden. So these three here, you've got further aft, you've got the diesel one. You'd see a large head valve sort of pipe coming up that's hidden by the casing of the tower under the winter garden. But if you were to strip that away, you would see a giant one here for the diesel air intake, and you'd see two smaller ones, one for intake and one for ventilation exhaust. Okay. Why is the one for intake missing? And that is because the boat has a snorkel. When it's operating underwater, it has the ability to replenish its air by way of the snorkel, and also feed the diesels with air by way of its snorkel. And so this intake one is actually gone, and so therefore you don't see it in Wolfpack. But here would be the ventilation exhaust head valve, and then the ventilation intake head valve would be right about here, and then the diesel one you can see they have. So now talking about the diesel one, again, head valve, foot valve type of arrangement. The head valve is here. The foot valve is in the diesel room, right between the forward ends of the diesel. It's a very prominent wheel right in the middle of the gangway above your head. That's the foot valve, and that, as long as the head and foot valves are open, the diesel is getting air from this into the intake trunk, and then into the engine. And they didn't necessarily have to do that. They could suck the air through the tower and create a nice little draft through the after end of the boat if they wanted to. But this is the actual technical way to feed the diesels with air, is having the head valve open, having the associated foot valve and the diesel room open, and allowing that air to flow down. Okay. When we covered the dive ready lamps in the previous video, so these right here, you'll remember I said there were 5 of them. 3 of those we just saw. So the 2 head valves for for air intake and exhaust each have an electric sensor on them, and the diesel air intake head valve has one as well. So boom, boom, and boom are right here. You shut these, you've got your dive, your 3 lights, at least 3 lights. You would have 3 lights on your ready lamp board lit up. The other 2 are for your external exhaust vents, which are in the diesel room. But these are 3 of the 5 right here. Okay, that's those. Okay, so that covers that. And the ventilation system, again, we can talk more about that as we go through the boat, especially in the diesel room when you actually see what the ventilator units look like. You'll be able to kind of maybe more visualize better kind of how that works, how that system works. Okay. All right, so the 2 now, as we kind of move into the real meaty portion of the video here, is going to be the trimming system and the regulating tank system. And in other words, the regulating tank system, you can consider what's technically called the flooding and draining system, and then you got your trimming system. They're 2 separate things. So the trimming system, if you want to think about it in terms of geography in the control room, you've got your trimming happens in the aft port part of the control room. Here is and then here. Okay, your trim controls are here, and then you've got more trim controls here because you've got your trim pump here. Okay, and then the aft starboard section is more of your flooding and draining. Think of draining the bilge, flooding and draining the regulating tanks. This is more buoyancy. I'm too heavy light is here. I am controlling my pitch trim is here. Okay, that's how that's sort of the delineation there. So you've got your trimming system, you've got your trim pump here. They've made it really more of a simplistic version of it here in real life. You've got a couple of gauges on there. Those are pressure gauges. One is going to show you your suction pressure, and the other one is going to show you your pushing pressure. So, the way your pump works is it's got a suction end and it's got a pressure end, right? You're sucking in water from one end at some particular sucking pressure, and then the pump is pushing by way of a motor. It's pushing that water out another side and off to where the water is needed. Okay, so the auxiliary drainage and trim pump is here, and this was used as really what it's for, as the name implies. It's a backup bilge pump for small amounts of water, and it's also the trim pump to the extent that the pump is actually used for trimming, which it not always, in fact, in most cases was not. Okay, you've got really 2 options to do trimming on a U-boat. You've got the option of using trim pump, or you've got the option of using low pressure air. When we covered the low pressure air manifold, the low pressure air distributor in the previous video, that would be this here, this manifold right here on the far right. That has a valve for the trim system, and that actually supplies this valve here, and this sort of arrangement right here is kind of the manifold for trimming with air. Okay, but you've got 2 options. You've got trimming with pump and trimming with air. All right, and I'm going to actually go through how you would actually go about trimming in practice with all the valves, etc. And I'll use, because there are some differences, and I'll just do a side-by-side comparison with like what these areas look like. And here there are some elements and some important elements that are missing. For example, this, if I can scroll in here a little bit, this thing here is there was a water meter that was actually inserted into this, and it looked like this is a different one that we'll cover, but it basically looked like this. It's a water meter. It's basically a way to see how much volume is flowing through the trim system when you're trimming. Say, pump 500 liters forward. All right, the guy is watching this and making sure 500 liters are going forward. Okay, so they've got that. There's a couple things that are kind of missing here. Or they're a little different. So I'll use this to explain how the system works. All right, so I guess we'll cover with trimming with the trim pump first. So you've got several valves that are on the trim pump, and let me get a couple other things open here just so I'm ready. So you've got two prominent ones here at the bottom. The one on the left here is your sucking connection for draining, for the drainage system. So like think of draining the bilge. And the one on the right here, this one here, is actually the sucking connection for the trim system. So if you were going to trim using the pump, what you would do is you would open this. This would allow the trim system to suck from whatever the other end of the boat. Essentially say, I want to trim forward. So in this example, let's say I want to trim so and so many liters from aft to forward. I would use the pump to suck from aft and push to forward. So what I'm doing is I'm opening this, and then I'm opening this. This is the water outlet from the pump. And then what I'm going to do is I'm going to open. There's two valves back here. The first one is more for the drainage system. The second one way back there, I'd reach back there and I'd open that, and that's the pressure connection for the trim system. So when I open these two valves, I'm effectively allowing the water. I'm allowing the water that's being pushed out by the pump to flow through there, and by this backside one, I'm allowing it to flow into the trim system. So from that point on, it will go through there. It'll come back forward, and you can see this pipe here. It's going to come up here. Now this here is called the trim controller. You've got a couple settings on it. It's really just a valve that you screw in and you unscrew. But if I screw it all the way in, I'm saying I want to suck from aft and push forward. So all the way in, like you can see it is right now, it's set for forward. So I have the trim controller cranked all the way down, meaning I'm pumping forward, and then I open this little trim valve down here. And at that point in time, what I can do is I come up here, and I go to this box right here, which is the motor for the trim pump, and I turn this wheel. 1 click, 2 clicks, 3 clicks, etc., based on how fast I want the pump to run. But this is how you're starting the pump. This is how you're running the pump. You reach up there, turn the wheel, a couple clicks, pump goes, and while you're doing that, you're watching the water meter to make sure that it's registering the amount of water that the chief engineer ordered you to pump. Okay, and you're watching, and then when you see the water meter read, again, just to reiterate, the water meter looks like this right here. Once you see it reading the amount of water that you want, you would cut the pump off, shut all the valves that you opened, and then you've now executed the order. You've now trimmed with the pump. Okay? So that's how trimming worked with the pump. More common was trimming with low pressure air, and the reason for that is probably obvious. It is much quieter to trim with low pressure air than it is to start the trim pump. And so certainly in a battle stations type situation, it is easier to do this, and it's also much simpler, as you will see. So again, you've got a connection from the low pressure air manifold back up forward there. You've got a couple controls here. Again, you still have these important ones down here that you need to manipulate, but you set this trim controller in the center position, meaning you would sort of unscrew it halfway. And what that has now done, it has opened this pipe up so that and has shortcutted and bypassed the trim pump. Now I've got effectively an open pipe here to go forward and aft. Okay, and I've circumvented the trim pump. So I put that in the center position. I open the trim valve, and then which is this one down here, okay? And then I take a look at and these are actually modeled in Wolfpack right here. you can see, this is the selector lever for what direction I want to blow air. So if I want to trim forward, what I'm going to be doing is I'm going to be admitting air into the aft trim tank, and that's going to blow the water forward. And any air that was in the forward, because again, something has to happen because you're increasing the air in your trim lines there. And you're moving water around. The amount of water stays constant, but you've got more air in there, so now there needs to be some venting element as well. So as you would, if I select, so this is currently in the trim aft setting. If I then turn this wheel right now, what would happen is I would blow low pressure air into the forward trim tank, and it would blow air or force water back into the aft trim tank. And I would again watch the water meter to make sure that I had the correct amount that was going there. That excess air pressure that's forced out of the aft trim tank by the water coming into it is vented through here and into a muffler down into the bilge. It's vented into the pressure hull. Okay. So again, one of the many things that causes an overpressure situation, and this as well, on a dive, you've got several things that are venting air into the pressure hull as time goes on. Okay. So this, you can see, that's that knob or that lever right there. You would pull it all the way to the left if you wanted to trim forward, and you'd pull it all the way to the right if you wanted to trim aft. And then this is your regulating wheel here. So you would turn this, and then you would watch the water meter down here to make sure you had the right amount going through, and then cut it off when you saw the right amount. Okay. And again, what's happening there is, in contrast to the way the pump works, the way the pump is working is it's sucking from one end of the boat and pushing to the other end of the boat. So there's no air being admitted at all. It's just moving water from one to the other. And then in a low pressure air type of trimming situation, you are blowing air into one end of the boat to push the water to the other end of the boat. Now you're admitting air into the system there, so air needs to get vented out. That the air that gets displaced on the other end needs to get vented out, and it gets vented out here through the muffler, through a muffler into the bilge, essentially into the pressure hull. All right, so that's trimming with air, and that's more common. And the dive regulations even state that too. Trimming is at periscope depth, which is where trimming occurred, is generally done. Really, in principle, is done with low pressure air. For that reason. Okay, so it gets quieter instead of starting the pump. Okay. All right, so that's the trim system. There's really nothing more that needs to be said about it. In terms of Wolfpack, I mean, you've got trimming. Well, there is really no trim element in Wolfpack. You don't have any sort of longitudinal instability where you're trying to get the boat on an even keel. It's just always by default on an even keel. But if they did want to implement forward and aft trimming, this is a pretty simple system here. I would really, say that the preference would be to just implement the air system, the air trimming, because that's really what was done near the enemy anyway, and it's also the simplest. I mean, like I said, you flip this handle one way or the other to say I want to trim forward or aft, and then you just turn the valve here, and then you watch this little meter here. One guy can do this pretty easily. And again, this has to be in the center position. This is only really used in a forward and aft trim situation, when you're using the pump to put it all the way down or all the way up. And when you're using air, you put it in the middle position so that you have that flow through there. Okay, so again, pretty simple with air. All right, so that's the trim system. I don't think there's really much else to be said about that. Now, the flooding and draining system. Now, this is a doozy. Okay, so this one might be a little confusing, but I will try my level best to make it as understandable as I possibly can. You've got capabilities here to use two different pumps to do really a couple different things. The other thing I was going to mention about the trimming system, I almost forget, is You of course need to put water in the trimming system before you can do anything with that water. And I will actually cover how the flooding of the trim tanks works, and in this section here, in the flooding and draining section. But suffice it to say, you need to have a certain amount of water in your forward and aft trim tanks as a starting point in order to be able to move any water around, and so that should be set as well. Okay, all right. So this in German, this is called the Flut- und Lenzverteiler. That is the flooding and draining manifold. This is this big bad boy here. It's very prominent back here, and there's even a little, I think in Dust Boat, they sit here. You can see the captain and Vanna sitting here even. It's, this is where this is how you manipulate the contents of your regulating tanks. That's also how you drain water from the bilge. So I guess before we start out, let's really just cover the regulating tanks and bunkers on a submarine here, on a U-boat. You've got two regulating tanks, port and starboard, and then you've got two what the Germans called regulating bunkers. So you've got regulating tanks 2, port and starboard, and then regulating bunkers 1, port and starboard. The regulating tanks are outside of the pressure hull right here. Regulating tanks 2 here is starboard, the other side port, and then aft of those, really off of the petty officer's quarters, you've got regulating bunkers 1. Now, in the fuel oil configuration, in swimming condition B, you've got those regulating bunkers are typically filled with fuel. Okay, and they're, instead of being compensated by water pressure from the header tank, they're actually compensated using air pressure. So you admit air pressure into those tanks to push the fuel out if you want to feed the gravity tank in the diesel room. So those are actually compensated using air. The other fuel tanks are compensated using water. But you have the capability to flood and drain all of those, and the methodology there was relatively specific. You've got 4 tanks to use. Maybe at the beginning of the patrol you only have 2 tanks to use because your regulating bunkers have fuel in them. Sometimes they left port without those regulating bunker, with the fuel in those regulating bunkers already burned. So let's just assume that you have no more fuel in the regulating bunkers. You've got 4 regulating tanks to work with. The way the Germans typically operated in terms of the use of the regulating tanks is they operated 2 as flooding regulators. So they would only say these 2 are designated to be, and those were typically I believe those were typically the regulating bunkers were used as flooding regulators. And then the remaining 2, this would be regulating tanks 2, port and starboard, would be used as draining regulators. One would be designated as a shallow drain, and the other one would be designated as a deep draining tank. And why would that make any difference? It's because you want to be able to have 2 different tanks that are pressurized to different atmospheres in order to allow you to drain at different depths. So the one that you've got, the regulating tank that you've got designated as your shallow draining tank, that would be they'd keep that about half full, and they'd pressurize it using high pressure air to about 2 to 3 atmospheres. And the way you would do that is, if you remember back in my previous video, you would come here. This is the blowing manifolds for the regulating tanks and bunkers are here. This is how you would admit air into those in order to pressurize them. And then remember, these gauges here that I covered in the last video, they were differential pressure gauges for the regulating tanks and bunkers. So you'd be able to see how much pressure you're exerting on those tanks, or how much pressure is in how high the tank is pressurized. Okay. So you'd pressurize that to 2 to 3 atmospheres. What does 2 to 3 atmospheres correspond to? That corresponds to the atmospheric pressure at about periscope depth, which is where you would be doing your draining, your shallow draining, if you needed to drain. Okay. The other tank, which would be about 2/3 full, would be your deep draining tank, and that you would pressurize that one up to about 10 to 12 atmospheres. In other words, the pressure that you would experience at or slightly below 100 meters, which is your standard depth to dive to for escaping pursuit. Okay, so that's why you would pressurize that to 10 to 12 atmospheres, so that you could operate the bilge pump effectively and not have this huge pressure head that you're working against. Okay, so you're pressurizing that tank to be roughly the equivalent of the outside water pressure. Okay, and so that's how you would use the regulating tanks. The flooding regulators, which would be your regulating bunkers 1, you would be admitting water into those as the patrol went on, because you are losing weight by way of provisions being consumed, by fuel being burnt. So the control room mate would be back here admitting, and I'll show you how he did that, but he would be admitting a certain amount of water, every day or whatever, into the flooding regulators to offset that weight. And he's using the dive log book, as I covered in the previous video, at his little stand that was further forward up there by the control room, or by the conning tower ladder. He's using that to record all of that, so he knows how much to put in to try to maintain, so that when they do their trim dive, they're not completely trying to fumble around and make huge adjustments when it could just go smoothly by them being prepared. So they would be admitting water into the flooding regulators incrementally throughout the patrol, right? And then your draining regulators would be used in a dive situation for shallow draining or for deep draining. Okay, all right. So we'll go over kind of how the manifold works here, for at least for this side here. And I already talked about these two. These are for the trim pump. This is your suction inlet for draining, for the drainage system, and then this is your one for the trim system here. Okay, but over here you've got basically the way water flows in here, and I mentioned this seed water intake here. That's this thing right here. This admits water into the flooding and draining system, and it also admits water into the distilling unit, which is behind us over here, sort of to our left. That's what also feeds that. And you can see this little wheel right here. That is a that I mentioned this very briefly in the previous video, but there's a blowing. You have the blowing ability here to blow debris out of the whatever is being admitted into this valve here, and that is what this is for. It's low pressure air to blow, like seaweed or whatever the case may be, out of this, so that you didn't have foreign objects floating through your system. Okay, so the water comes in here. That's your external sort of hull valve for admitting water in. In the interest of redundancy, we've got an internal from sea valve here, and then we've got another valve here that we open if we want the water to come into the regulating tanks. Now the regulating tanks are there's 4 valves here, and Wolfpack has these modeled. You can see they have these 4 modeled. These are for the regulating tanks and bunkers. You've got so regulating bunker 1 port, regulating tank 2 port, regulating bunker 1 starboard, and regulating tank 2 starboard. That is your ordering there, okay? And they're labeled. But basically, the water would come in here, and it would come into the regulating tanks there for flooding, okay? And if you wanted to use the trim pump, the water would come up through here, it would come through here, and the pump would do its magic, and then either come into the regulating tanks here, or into this section here, and either directly outboards, or into main ballast tank 3. We'll cover why that's the case here in a minute, okay? So that's what these are here, and then this valve here is your drainage connection for the main bilge pump. That's going to provide your connection actually to the main drain line, which is actually running down the center of the boat here. That's your main line to drain the bilge, is essentially straight up through the boat, forward and aft. You've got a few different valves here. You've got one for draining aft, your aft compartments. The middle one here is for draining the aft control room, and then this one here is an intermediary valve for draining the foreship. So in the draining the forward portion of the boat, you need to have this open if you want to drain forward compartments. Now you may remember you also have these here. These are the drain valves for the various compartments forward that are able to be drained. So you'd have to have these open, and then you'd also have to have this, well, it's not modeled here, but you'd have to have this open as well to drain forward. We'll cover all the draining, and we'll cover everything exactly how it works step by step as we go here. But and then this right here, you can see this little black thing. That is actually this. I've opened this picture was courtesy of Patrick, of Engineer Guy. For those of you who don't know, he's actually in charge of like the restoration and some of the projects that are going on at U995 in Labour in Germany, and so he has access to the boat like none other, and he's provided some excellent pictures, particularly for this video series here. And so here you go. So that's what this is the water meter for flooding the regulating tanks, similar to the trim system, where you want to admit a certain amount of water in the system. You want to be able to have a way to tangibly measure what that what that is. And so you've got all these that's what all of these valves sort of at high level what they do. Okay, and we will cover procedures in a minute here. But now if I look over to the left here, I've got a couple sight glasses, and these are also something that sometimes people look at and they're like, what the heck are these? They are gauges. They're sight glasses. You've got one for, you can barely kind of see the numbering system on them, but actually this is for the first one here is for the contents of starboard regulating tank 2, the bigger one. The regulating tanks 2 each tank had the capacity for about 7.9 tons of water, of cubic meters of water. And then each regulating bunker had about the capacity of about 4.7 tons or 4.7 cubic meters of volume for that. Okay, so this is for regulating tank 2, and this is for regulating tank 2 starboard. This is for regulating bunker 1 starboard. If I come over here, excuse me, I have 2 that are in different positions and sort of reversed. I've got one for regulating tank 2 port back here, and I've got the one for regulating bunker 1 port here. Okay, so that's a way for you to see the contents of your regulating tanks at a glance. Okay, so that's very handy. Now Wolfpack has these modeled. They've got them modeled to an extent here. They've got both of those here, when in reality the one for regulating tank 2 should be back here. Okay, but they've got them both right here. But that's what these are. They're sight glasses for the contents of your regulating tanks and bunkers. All right, so that's what you've got there in order to tell how full or empty your tanks and bunkers are. Okay, so that's sort of the layout of the regulating tanks and bunkers, how they were used and that type of thing. We'll go through kind of the different ways to get water in or get water out of the system. So really the first consideration, or the first thing you could do, and again to reiterate, this is the main bilge pump here. This is the main bilge pump here. It works a little differently than the auxiliary bilge and trim pump, in that this has really 2 motors in it, 2 impellers, and you're able to operate it either in series mode, which again will give you more power, more pressure head power, and then you've got parallel mode, which will be a little lower power, but it'll give you actually more volume of flow. Okay, and again you've got a gauge for you got a pressure side gauge, and you've got a suction gauge, and again Wolfpack has taken some creative license and made this your bilge level, and then this your compressed air. one of the recent times I played Wolfpack, running the bilge pump actually reduces your compressed air. That should not happen. There's no air associated with the pump with pumping. You're simply using a motor to pull water from one place and push it someplace else. There's absolutely no air being admitted into the system at all. So that hopefully that'll change in the future. And the other thing too is when you're operating this is not the on valve, the on switch. This box here is actually the motor, similar to what we saw for the trim pump above. This box is actually the motor for the main bilge pump, and that this has a handle on it that has like 3 settings, 1, 2, and 3, and that's your speeds for the pump. It's actually here. So maybe if we're lucky, they'll change it so that you actually click this and actually operate the drain pump from where it actually was operated from. Okay. All right. So that's just a little aside on what we're dealing with here in terms of the main bilge pump. So you need to get water into the regulating tank somehow, right? So you can do so one of two ways. You can flood it naturally, but that's only going to get your regulating tanks up to the water level that's outside the hull. If you want to get it further than that, you need to artificially flood. So we'll cover how both of those work. All right. So if you say it's the beginning of the patrol or whatever, and you're actually doing your Trimversuch, you're doing your initial sort of trim attempt to try to get your regulating tanks to the right levels to start the patrol, you get the order, let's flood the regulating tanks up to the water line as far as they'll go. Okay, that's called natural flooding. The first thing you would do is you would open your from sea external here. Then you would open your internal from sea here. You want to put water into the regulating tank, so you need to open this valve here, which will allow water to come into this set of drain valve of valves here, one for each tank. Now, if I want to do, depending on what tank I want to flood, I would open that particular one. Now, sea pressure is admitting water into the tank, and I'm watching the sight glasses here and watching my water fill up, and it will stop once it gets to the equivalent of where the water level is external to the hull. Okay, but in order for me to do that, there's actually one other element of the regulating system that I haven't mentioned yet, and it's these right here. So you can see 4 valves here. On Wolfpack, they're not really modeled. They're kind of modeled, but they're just different. Looks a little different, I guess. 4 of these, one for each regulating tank and bunker, and these are your vent valves. It makes sense. If you're going to be admitting water into a closed area, you need a way to vent it. You need a way for the air that's getting displaced to move out, and that's what these are. These are your vent valves for the regulating tanks and bunkers. These here are actually sight glasses, and you can see the same thing if you look back at this picture of these gentlemen here operating the vent valves. You see, here you go. Here's the vent valves for the regulating tanks and bunkers. Here's the sight glasses right here. These sight glasses are just to make sure that no water is coming down into or fuel for that matter is coming down into the bilge. Okay, and because what's happening here is you've got air coming down through these pipes, and you can barely see right behind this trim pipe here. You can sort of see this. That's a muffler, and that is the air is coming down there and venting into the pressure hull through the muffler. So the air that was in the regulating tanks and bunkers, whatever is getting flooded, is getting vented into the pressure hull through these vent valves here and down through this muffler here. So these always need to be open when you're operating, when you're doing flooding and draining. Some of them stayed open all the time. Some of them needed to be shut for various reasons, but suffice it to say those are important as well. Okay, so that's how you would naturally flood. You'd say, all right, I want to bring water's coming in here, it's coming in here, it's going through, I'm opening this, that's coming through here, and then I'm opening whatever valve for whatever tank I want to flood. That's natural flooding. But it's only going to take me up to the water line that's external to the boat. If I want to go higher, I need the pump. So if I want to pump the water in, pump more water in above the level of the water outside, I need the pump, and I could either do that. I have to do that with the main bilge pump. And so the way that works is I would do the same thing. I'd open up the external hull valve to allow water in, and I open my internal one. But instead of opening this, because I don't want water to go directly into the, I can't get water directly into the regulating tanks without the help of the pump. So I have to bypass this. So I keep this closed. The water's going to flow through here. There's a valve right here. You can see it. That's the entry valve or the intake valve for the main bilge pump. You've got, it's going to come through here. The pump is going to do its magic. Now you've got another set of valves right here. I've got two options. I could either send it to the regulating tanks, which is what I want to do, or I can send it to pump outboards. I want to send it to the regulating tank. So I open this one here. The water flows into here, and then I select whatever one that I want to fill, make sure that the vent valve is open over on the periscope well, and I'm flooding that artificially using the bilge pump. I'm flooding that regulating tank further. Okay. I guess an aside with, well, I'll cover that in a minute. We'll cover the output, the capabilities of the pumps in a minute. So that's really your artificial flooding. You also have another option too with if you want to use, if you want to drain water from the bilge and put it into the regulating tanks, you can do that actually with the auxiliary drain and trim pump. And the way you would do that, is you would, again, you've got two valves down here. One is for, the one on the left is for your draining. Okay, so the one on the right is for trim, which we're not doing right now. We want to have this open. We want to have this exit valve open, and then I want to, if you recall these over here, there's two of these. The first one is what I want to open for this, because that's going to be my 2C valve out of the drain pump in 2C. So it's going to come out of there. The water is going to get getting sucked from the bilge out that valve, and now it's coming over here, and I want to get it into the regulating tank, so I have to actually open this valve and this valve here to allow that water to flow through, and then I would select the regulating tank that I want. Okay, and we'll cover what the additional steps that you need to do in order to drain the bilge when we get in a little while, but that's how you would empty the bilge into the regulating tanks. It's also another option. I mentioned earlier the ability to admit water periodically through the patrol, or I guess the process of admitting water periodically through the patrol to offset any weight loss from consumption of provisions, etc., or fuel. The way that would be done is actually by way of fine flooding. So, if you may have noticed, like when you're admitting water, from sea using these, it's kind of laborious. There's a lot of things you have to turn, and you have to use these, which are kind of, maybe they're a little hard to read exactly. So what the engineers decided to do is they said, you know what, let's actually make the capability of fine flooding. So a fine flooding arrangement such that all you have to do is just open a couple of valves, and you're able to admit water into the system without having to, use the pump or use a series of other valves and a rough sort of sight gauge in order to determine an amount of water that you've added. So, because again, say, hey, control room mate, we've consumed so and so many kilograms of food. Okay, well, what is that in terms of water that I need to admit? And that's how he would know. And in order to measure that, he uses his water meter. And this water meter is for fine flooding. That's what it's designed to do. So in order to make that happen, you've got a valve up here. You can barely see it right there. You'd open that one. That's your external one to admit water into the boat. You've got, this is your internal from sea valve, which some boats didn't have this. U995 does have it. Open this, open that, open the regulating tank that you want water to go into, and then make sure, of course, that your vent on the periscope well is open. And then you're simply reading the water meter, and then you would close it off when you were done, and then shut the valves. That's how you fine flood. Just I'm admitting water into the boat to offset weight loss. Okay. All right. So now you've got the capability of draining the regulating tanks with either the main bilge pump or the auxiliary bilge pump. Now, why would you do this? I mentioned before that you've got when you're doing your trim dive or you're operating at periscope depth, you're usually using low pressure air to do your trimming, and you're also generally using air, or in this case high pressure air, to do any draining of the regulating tanks at periscope depth. Because if you remember from what I mentioned a bit ago, you had a shallow regulating tank, shallow drain tank, and a deep drain tank. One designated for shallow, one designated for depth. And you've got them pressurized at different atmospheres. You've got the shallow one pressurized 2 to 3 atmospheres to correspond to periscope depth, and then you've got the deep one at 10 to 12 atmospheres to correspond to the pressure at like 100 meters or so. When you're at periscope depth, if you do need to drain, you could use high pressure air to make that happen, or you could use the pumps. It doesn't really make much of a difference, but the diving regulations say that basically you could pump water from the shallow drain using air, or it's actually handy to also use the trim pump to drain from a flooding regulator, because again, you've got 2 tanks that are designated as your flooding regulators. You could actually use the pump to drain from the flooding regulators so that you don't upset the trim or the regulating tanks that you have set up as your deep and shallow draining tanks, because you've got those pressurized already. And so you could use the pump to drain from like the shallow drain tank, but why do that when you could just do it from a flooding regulator, in which you don't need to worry about repressurizing that shallow tank again? So it's actually that's why they mention it. It's actually a little confusing, but because typically it's like, well, why do you have a shallow draining tank if you're not going to use it? Well, you can use it, if you wanted to in a pinch, but if it's convenient, you can just use the pump. Now, when wouldn't it be convenient? Well, it would be if you have to drain in the proximity of the enemy. Then you don't want to start the pump. Okay, then you'd be using air to drain from that shallow drain regulating tank. But if not, and if it's easier, you just take water out of the flooding ones with the main bilge pump and call it a day. That way you're not upsetting the tanks that you've already pressurized. Okay, so if you do want to use the pump for draining the regulating tanks, this is how you'd go about doing it. You'd using the bilge pump. You would do, if you were at periscope depth and doing it, you'd have your pump set in parallel mode. And if you were doing it at depth, very deep, you would set it in series mode, so you get more pressure output. So the way that would work is you say, okay, I want to get water out of the regulating tanks and out and outboards into the ocean. So I work in reverse. I make sure I have my vent valve open on the periscope well, and then I open whatever valve for whatever regulating tank I want to empty here. Okay, and then I want to use the pump, right? I want to use the pump, and so what I have to do is I make sure that this is closed. The water is going to get sucked by the pump. It's going to get sucked out of here. No, excuse me. I need to have this open because I need the connectivity between here and the pump. So I need to have this open. It's going to suck out of here through this valve here, and I need to open that through the pump. And then instead of this one, this is my 2C. I open this, the water flows through here, and then I have 2 options. I can either I can either have it drain directly out into the ocean, or I can, and this is the more preferable way, is to actually push it into main ballast tank 3 under the control room, and then it would go outboards. Why would I want to do that? And it's because and this is particularly the case if you're draining the bilge, you may or may not have oil in whatever water you are draining, okay? You don't know that. And so because the bottom of main ballast tank 3 is open, the Kingston valves are always open, you can push any drainage water or regulating tank water or whatever into main ballast tank number 3. Fuel and oil floats on water, so by pushing that into main ballast tank 3 instead of directly outboards and potentially causing an oil slick, you could push it into main ballast tank 3. The water that's at the bottom of that tank will get pushed out first, and the oil will stay in the tank. And while you're submerged, you've avoided any potential oil from escaping the boat. That's why there's 2 options to drain here, and that is actually why that's actually the more preferable way. So water would come through here and then out into MBT3 here, or directly outboards here. This here is actually in addition to later boats like 1942 and forward. This is actually a way, my understanding of this is actually a way for them to drain the regulating tanks with high pressure air more efficiently into MBT3 versus having to circumvent some of these other, having to use some of these other valves. This is a way to directly get water out of the regulating tanks into MBT3 easily. Okay, so that was 995 is a little different in that regard. It has this kind of extra valve here. Okay, but that's how you would drain from the regulating tanks out into the ocean. Okay, and this was done typically. It could be at periscope depth, but typically air was used. However, when you're deep, you're really kind of limited to using the main bilge pump. You're down at 100 meters. You have got you've got draining happening really at 2 stages. You've got if you are heading down from a shallow depth to a deeper depth, the water pressure is causing your boat to contract and the volume of your boat therefore to decrease. And when the volume of something in water decreases, it loses buoyancy. So effectively what's happening is the boat is becoming less buoyant. It's sinking faster because the water pressure is compressing the hull. So what has to happen then when you dive from a shallow depth to a deep depth is you need to actually drain water out of the boat. It's counterintuitive, but you need to drain water out. And generally, that means about a ton of water every 100 meters. So if you're diving to 100 meters, you need to get a ton of water out of the regulating tanks. And so that would be done before, as they were diving down, they would use the main bilge pump they could use the main bilge pump or they could use high pressure air to do that. Why would you use one or the other? You have a limitation on the use of your main bilge pump depending on how much pressure is being exerted from the regulating tanks onto the pump. That pressure couldn't exceed like 8 atmospheres. So if you had, this is exactly why you have differential pressure gauges over on the blowing manifold over here, so that you can see what is my internal tank pressure, what is my outboard pressure. I can't, if my internal pressure is greater than external pressure by 8 millibar or by 8 atmospheres, I can't use the bilge pump because I'm at risk of rupturing something on the suction side of the pump. Okay, in that case, I'd use air. I'd use air pressure to get the water out of there. If I had enough of an overpressure situation in my regulating tanks, I'd use air to get that out of there. But if the disparity in internal and external pressure were a little lower, then I'd use the pump to get the water out of there. But at any rate, I need to be draining about a ton going down to 100 meters. So that's happening as I'm going down to that depth to offset the loss in buoyancy from the loss in volume of the boat. Okay, and then if I need to do any more draining while I'm down there, I would do the main bilge pump. But ideally that wouldn't be happening because you may or may not be being pursued at that point in time. So you need to do it while you're heading down, and that could be either with air or with the pump. And while you're down there, again, you're using the pump in series mode versus in parallel mode to get that extra pressure power to be able to pump the water out. Okay. So that's draining from the bilge pump. Now you can do the same thing from the trim pump, and it's just a little more, couple extra little steps here, right? So you've got, again, I want to start with my regulate valves. I want to open the one that I want to drain. I'm going to be using the auxiliary bilge and trim pump for this. So I open this, open the vent valve. I need to open this one now here. That provides me a connection to the auxiliary bilge pump. So I open this, I open this one to allow the water to flow over here. I open and then the process is actually substantially similar to before. From here on out, I open my bilge connection here to the suction end of the pump. The two exit valves here I need to open, and then the water is going to flow over here through this one here, 2C, and then it's going to flow either to MBT3, which is more common, or it's going to flow directly outboards here. So that would be how you would do it, draining the regulating tanks from using this the auxiliary pump. I mentioned flooding the trim tanks. We'll cover that in a minute. The one thing I didn't mention when we were up in the forward torpedo room is the flooding of the torpedo compensating tanks. So that is actually done locally up there, and I mentioned on the starboard side forward where the door is in 995 now, the devs assumed that was another air purifier unit there, and what it actually was the manifold for flooding the torpedo compensating tanks. There was another water meter, so another one of these up in the forward torpedo room, along with a manifold of valves in order to flood water into torpedo compensating tanks 2 and 3. So that was the ability to do that actually from up there, and I didn't cover that up there, but that's part of the flooding system is doing that. Okay, so then you also need to put water into your trim tanks in order to start off the patrol. In order to use the trim tanks, you need water in them because you need water weight to move forward and aft. So how do you do that? Well, we're admitting water into the system, so we need to have our C valves open. 1, 2. I need to get water over here. So that means I need to open this to get water into this manifold here, and then I need to open this so that water flows over here. Now I need to still use the suction side here because I'm not sucking from the trim system, I'm sucking from outboards. So I use the suction intake for the drainage part of the pump here. Suck it in. Again, open the valves over here, but then I need to open the trim, the far one behind here, to admit so that the water gets directed into the trimming system. And then I need to make sure that I have my trim selector selected to the appropriate tank that I wanted. So that's either going to be screwed all the way in order to direct it to the forward trim tank, or unscrewed all the way out. My trim controller is screwed all the way out to direct it to the aft tank. And then I'm reading on the water meter how much I'm admitting. Okay, and then I've got the trim valve open. So I'm watching that to make sure that that I've got what I need. And again, in order to do that, to run the pump, I have to come up here and I have to turn the wheel to start the motor, and then watch that. I watch that water meter here to make sure that I'm flooding the right amount, and I can do the same thing for aft. So that's how you flood the trim tanks. It's also important. Okay. All right. So then we covered the regulating tanks. Now we cover the bilge. So, this is obviously an extremely important functionality of these pumps is the fact that they are use to drain the bilge. There's also the option of a hand pump. There was a hand pump that was available as well to do this, and that's actually what they do in Dust Boat, I believe, is they use a hand pump because both of their pumps are out of commission. And so to drain the bilge, they get all of the water into the control room bilge, and then they pump it into a regulating tank, and then I think they use high pressure air to blow it out. Okay, so so I got water in the bilge. I could have water aft, I could have water in the control room, and I could have water in the forward compartments. So in order to make that happen, I have these set of valves here, and I mentioned these before. Each compartment, though, has its own, most compartments back here have their own drainage valve that needs to be open, and there's also a foot lever in each compartment back here to allow the compartment to drain into the bilge, into the draining system from like locally as well. But there's, suffice it to say, there's a drain valve up in here, and then so if I want to do aft, I would have that whatever compartment drain valve open back here, and then I would have this valve open here to drain the aft part of the boat. Okay, so then I would have, if I want to use the main pump, I'd say, okay, I have this open, water's flowing through here. I need to have this open in order to get water back into the intake. So I'd have this open. Water would flow into the top of this manifold here. It would flow up through here, through the intake to the pump. The pump would do its magic, and then I want to drain the bilge outboards. So I actually want to have this open. This one would put it back into the regulating tank manifold here. I want to have this one open, and then I can select where I want the water to go, directly outboards or MBT3. All right. If I wanted to do the control room, aft control room, I would open this and do the same thing. And again, I'm starting the motor by this box here. Okay. And if I wanted to do the aft control room, I'd do this one. If I wanted to do any of the forward compartments, I would have to have this open, and then I'd have to have the associated valve open in the forward part of the control room as well, and then I would do the same thing. That's how you use the main pump to drain the bilge and the various component elements of the bilge forward and aft. Okay, so that's that. Again, you've got really two bilge pumps. You've got your auxiliary as well, auxiliary bilge and trim pumps. You can do the same thing here. You can say, all right, what do I want to have? What part of the ship do I want to drain? Aft control room, forward compartments. Have that particular one open. I use the left-hand one to do my draining. So that's going to suck the water up into here. Again, I'm going to open the 2C one, outboards, and that's going to allow my water to flow over here, through this valve here, and then here, or to MBT3, which is more common. So that's how the draining system works. That is from A to Z about how this operates back here and sort of all the different uses that it would be used for. I apologize if the whole deep flooding and shallow flooding, or deep draining and shallow draining thing is unclear from before, but remember, you got 4 regulating tanks. You're using 2 of them as flooding regulating tanks, and you're generally not taking water out of them. The exception is if you want to use the bilge pump at like periscope depth while you're trimming, in order to not have to touch your draining tanks. Okay, but you got 2 flooding regulators that typically you're only adding water to them, and then you've got 2 one you've designated as your deep draining, and that's pressurized to about the same atmospheric pressure as you would find at about 100 meters depth. And then you've got one for shallow draining, and that's pressurized to the same pressure that's about at periscope depth. Okay, so you got the capability to do pumping, to do draining shallow and draining deep, and you're pressurizing them to the pressures so that you can efficiently use the drain pump to get water out of the boat. Okay, so that's what your regulating tanks are used for. And again, you're admitting water using the fine flooding system here. You're admitting water in there incrementally. Your control room mate is doing that to offset the weight loss from consuming provisions and fuel, etc. So So that's the entire system, kind of in a nutshell. The other thing I'll mention too is there's this concept of traveling on an air bubble. So you had the option to, if you were at silent running, typically you've got minimal RPMs, you've got several pieces of equipment that have been shut off. The boat is, and you're deep, the boat is going to inevitably take on water at depth. It's just not sealed 100% such that water doesn't get in. Water is always going to leak into the boat at depth. Okay? You've got a tremendous amount of pressure being exerted on the hull. And so what ends up happening on a U-boat is the U-boat tends to become stern heavy at silent running. And so the chief engineer had the option to admit air into main ballast tank 3, which is in the center of the boat. It's under the control room, to essentially blow those tanks a little bit, just a little, not a lot, and travel on what they call travel on an air bubble. By doing that and having that pocket of air in the center of the boat, it allowed him a little greater control over his trim dynamically using the hydroplanes versus having to drain aft, because he would have to run the noisy drain pumps in order to do that. And so traveling on an air bubble was an option for silent running. Okay, so that you'll see that in the diving regulations, and it's really obscure. Like, what are they talking about? Traveling on an air bubble? That's what they mean. You're blowing air into MBT3 just a little bit, such so that it gives you a little more trim control to offset your the fact that you're stern heavy. Okay, so that's the only thing I'd really mention there with regard to kind of trimming and operating at depth, etc. I should mention the capabilities of these pumps. And so again, the main drain pump has the capability to be run in parallel or in series. In series, it had and the series is again used typically at depth because you need a higher pressure head. That you were able to pump 500 liters per minute at 100 meters. So that was the kind of the output, 500 liters per minute at 100 meters. In the parallel setting at shallow depth, so say 14 or 15 meters at what would be periscope depth, that had the greater volume output of 1300 liters per minute. Okay, so that was kind of the output of the expectation for the main bilge pump now, or main bilge or drain pump, or whatever you want to call it. The auxiliary drain and trim pump had one motor in it, and that had it was a pretty standard output of 360 liters per minute. So again, this would be used obviously for trimming if you did choose to do so, although it was not typical to do that at periscope depth, was trimming with air. But you could, if you had a small amount of water to drain, your option would be, maybe the more preferable option is to use the auxiliary pump. Okay, but as a rule, I mean, draining was typically done with the main bilge pump. Okay. So I think we beat the system to death. I think we'll wrap up this particular system and just maybe talk a little bit about who worked back here. So I mentioned in the previous video you had a Centrale Mat, who was your control room mate, and then he had a Centrale Gast, who was his assistant in the control room, more of a basic control room technician, that he worked under the control room mate and was responsible for different things, including the pumps, periscope, that type of thing. So that Centrale Gast would typically be back here in this area. That Centrale Mat would typically be up at his station by the blowing manifold and by his little podium desk. If I go back to Wolfpack here, like Centrale Mat would typically be up here, because on surfacing he'd be the one to operate the blowing manifold here. That Centrale Gast would be back here, executing trim orders and executing any draining or flooding orders here. Now at battle stations, you'd have would have the additional control room mate actually coming up here to help that Centrale Gust, who is back here, pull the vent levers like you see these guys doing here. You know, one of these guys is likely the Centrale Gust, and the other guy is probably the other control room mate. It's typically, the roll table is typically designated the additional control room mate to come up here, since he's probably in here anyway. This is where he sleeps, is in the petty officer's quarters. You know, he would be he'd be jumping up on alarm and coming here and then hitting these vent valves, or these vent levers here, to pull them down. This one, if you can do 2 and 4 because you don't have fuel in it, pull those down, but then certainly MBT3 and be flooding those. Okay, so you'd have, you know, you'd typically have on a dive situation, like on diving stations or battle stations, you'd have the Centrale Gast back here, and then you'd also have the other control room mate being back here to manage all of these different responsibilities. So you're flooding and draining, and then you're trimming, which most likely was done with low pressure air at a periscope depth because it's quieter. Okay, so that's really who worked back here. So really, I did not lie when I said the aft control room is chock full of functionality and importance. And you know, it's another long video. You know, it might be a long slog, but you know, hopefully it's informative. I tried to go through the systems as detailed as I could. You know, Wolfpack has some of the stuff modeling here. Some of the stuff looks, you know, is not here. I would, you know, hopefully, again, and I say this, and I'll repeat this in all my videos. You know, hey, you know, if they'd like to do some additional modeling of some of these other components here of these systems, you know, there's people out there, several of us, that, you know, we know how these work. You know, maybe some sort of compromise could be found where we could actually, you know, we could operate some of these to operate the regulating tanks, etc., and maybe even in a simplified manner. But you know, suffice it to say, you know, I think some of this is an opportunity to maybe flesh out the gameplay a little bit by having some more of these controls being operative, and so, or operable. So that being said, that's the episode for the aft control room. If you have any questions, as I always say, you know, reach out to me in the comments, or certainly you can ping me on Discord. I'm Stoss on Discord, or Stoss as I'm sometimes called. And so, you know, feel free to answer. I'm never gonna turn down somebody who wants to learn more about these boats. And so with that, I will call it a night and say take care, and stay tuned for the next video, in which we will cover likely the tower interior and the bridge. All right, thanks guys, take care.